Welcome to this tutorial on JvmField, an important annotation in Kotlin for Java interoperability. JvmField allows you to expose Kotlin properties as Java fields, enabling direct field access from Java code. This is part of our Kotlin Interop series, where we explore how Kotlin and Java work together seamlessly. Before we dive into JvmField, let's understand the problem it solves. In Kotlin, properties automatically generate getter and setter methods for Java interoperability. While this is convenient, sometimes you need direct field access without these accessor methods. This is where JvmField becomes useful, allowing you to bypass the automatic generation of getters and setters. JvmField is an annotation that instructs the Kotlin compiler to expose a property as a public field in the bytecode, instead of generating getter and setter methods. This provides three key benefits. It enables direct field access from Java code, bypasses getter and setter generation entirely, and improves Java interoperability by making Kotlin properties behave like regular Java fields. The syntax for using JvmField is straightforward. You simply place the @JvmField annotation before your property declaration. Here's an example. We have a user class with two properties. The first is a variable property named name of type string, initialized to John. The second is a value property named id of type int, initialized to 42. Both properties are annotated with @JvmField, making them accessible as public fields from Java. JvmField is particularly useful with companion objects. In this example, we have an app_config class with a companion object containing constants. The API_key is a value property set to ABC123, and timeout is a variable property set to 5000. By annotating both with @JvmField, these constants become directly accessible from Java code without needing to call getter methods. There are three main scenarios where JvmField is beneficial. First, when working with Java frameworks that require direct field access to properties. Second, for exposing static constants in companion objects, making them easy to access from Java. Third, in performance-critical code where you want to avoid the overhead of getter and setter method calls, especially in tight loops where every method call counts. JvmField has several important restrictions you need to be aware of. First, it cannot be used with private properties since fields need to be accessible. Second, it cannot be used with properties that have custom getters or setters. Third, it cannot be applied to open, override, or const properties. Finally, it cannot be used with latnet properties. These restrictions ensure type safety and maintain the integrity of Kotlin's property system. Let's compare Kotlin code with and without JvmField. On the left, we have a person class with a name property without the annotation. On the right, the same person class but with the @JvmField annotation applied to the name property. While the Kotlin code looks similar, the difference becomes apparent when accessing these properties from Java, which we'll see next. Here's how the difference manifests in Java code. Without JvmField, accessing the name property requires using accessor methods. You call getName to retrieve the value and setName to modify it. With JvmField, you can access the property directly. Simply use p.name to read the value and p.name equals to set it. This makes the code more concise and familiar to Java developers who are used to working with public fields. When using JvmField, follow these best practices. Use it for public constants in companion objects where direct access makes sense. Apply it when Java frameworks explicitly require direct field access to work properly. Consider the encapsulation trade-offs before using it, as exposing fields directly bypasses the benefits of property encapsulation. Finally, document why direct field access is needed in your code, so other developers understand the reasoning behind this design choice. Let's recap the key points. @JvmField exposes properties as public fields in bytecode rather than generating getter and setter methods. It enables direct field access from Java without accessor methods, making interop more natural. It's commonly used with companion objects for constants that need to be accessed from Java. Remember that it has restrictions on property types and modifiers to maintain type safety. Finally, while it improves Java interoperability, it comes at the cost of some encapsulation. Use it wisely when direct field access is genuinely needed.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.